questions. Let us come up with a little more uh, questions that will make us a little more involved and that would make us more interesting. So I gave you an image of uh, the TCP protocol. Fine. The packet format. So let us get with the TCP protocol and let us again get something like this is what we did also. Let us understand this once again. Now we have two ends. The first end is my sender and this is my receiver. Fine. So this receiver sends a request. This receiver sends a request. Now, upon having this request, this sender will come up with a SYN or synchronizing signal. This SYN bit would be followed by an acknowledgement. Keep fine, I have got your request and I am to process. Means like the communication channel has been created. The logical channel, not the physical one. Now, once this synchronous acknowledgement has been sent, this means the logical channel has almost been created, and then this sender will send a final acknowledgement that your syncing is complete. Now you can ask me for whatever data you want. Now, once this acknowledgement is there, the sender will then put on the request. That would be followed by my request, and that request would be followed by the file. So this is the protocol for my TCP, Transmission Control Protocol. As against UDP, where what we did was this request acknowledgement frame file. As against my UDP protocol, where the receiver sends a request and that is met by responses, multiple responses, so that even if there is loss of packets or loss of data, that does not make a lot of difference. The difference between this TCP and UDP is UDP does not create this logical channel. No logical channel is created. So what happens is the data is sent on the complete channel, and whatever is my source, like every data packet would have a source and destination packet. Now, in case the destination address matches with my address, then I will accept the data and I will start process. But in case the destination address is not matching with my address, I will certainly have the data, but I will not process it. So the data will die in the time to live period. Now it will live up to the period that is in the TTL. Now once that TTL period is over, the data would die. I hope that was clear to everyone. Now, I hope you guys were able to catch up with the difference between the TCP and UDP transfer. Now, in case anyone has any question, just let me know. Now, guys, anyone was unable to understand, just let me know. Fine. I hope that was clear for everyone. So, no one has any question. In that case, let me come up with the packet structure. So, in case I talk about the TCP packets, it would be a little, there would be a little difference between the IP packets and the TCP packets, but major functions are same. Like there's only a structural difference. A little more fields were there in the IP packets. So we have this here at 0 bits and here at 31 bit number. So 31, 0 to 31, that would make my 32 bit. So this is a 32 bit architecture. So let me divide it. The first would be the 15. This would be one of the most important fields. First is the source, that is 16-bit source, and the destination port. Means the address of the source and the destination is there, 16 bits each. The next is my sequence number. I hope you understand the source. Who is sending the packet and destination for whom this packet is. Though we are not having a logical, even if suppose somehow this packet reaches a place where it was not supposed to reach, the destination address would be matched, and because the destination address on this packet and the destination address of the device does not match, that packet won't be processed and the packet would die itself. The next is my sequence number. I hope you remember the sequence number that we discussed in the first half. Now suppose I have 10 packets, so this sequence number would provide you what is the number of this, what is the exact location of this sequence. Now it will tell me whether it is the 9th or 15th packet. Now suppose I am downloading a movie and each movie is this movie is 100 MB and I have 10 packets, 10 MB each. So I need to know which packet to put where. So it will do the same thing, the sequence number of the packet. That would be followed by my acknowledgement. Now, to understand what acknowledgement is and why this is so important, we discussed and we drew this. So we have two acknowledgements, one for the synchronizing acknowledgement, and one is the acknowledgement that this logical path has already been created. So that would be my acknowledgement bits. This acknowledgement would be followed by a few bits. They are my flags. The first would be my header length. Then a few more flags like MLP, that would be followed by a reserve flag. This reserve would be followed by some offset codes, some offsets, and this would be followed by another offset. So we will talk about these offsets. This would be followed by a checksum. We discussed what checksum is exactly about, just to check whether the packets I received is corrupted or it has been uh, like someone has made some changes to my files. This would be followed by a pointer, that is another flag. This pointer would be followed by some optional fields, some optional flags, some optionals. Now, this option flags might take up to 24 bits. That would be followed by some padding. And here we have the data on my payload. Data on my payload means like what exactly I did send, that is right here. So, guys, I hope you guys are with me. I'm not sure. Did anyone understand anything? Like anything you understood of this? This is how my data packet would be. This till the data till here, we would be calling it the header. This header is very important since it is giving you where it originated, where it is supposed to go, the sequence number of the packet. This is these are important. Acknowledgement number might not be that important, but these three are very important. That would be followed by my checksum. But let us discuss each and every field of the packet. Are you guys able to understand what this packet is? And what is the purpose it is fulfilling? Very few people have joined in, and many are moving out. If Akash is trying to write anything, we'll wait. A bit confusing, I understand. Even I am feeling the same thing. So what I would suggest is, like, yeah, you guys speak as much as you can, so that we might make it, like, let us make it a little more interactive. So let me take another sheet. So suppose I have to send a large file, 1 GB of file, right? So I can use three different modes. This is what we discussed in our first session, right? So I have 1 GB of file. I can use three different modes. The first mode was simplex. Now what happens in the simplex is, you start the communication and you send it. You can send data in one direction only. You cannot have an acknowledgement, or someone from the other end, receiver end, he cannot send anything back. Nothing can be done. So that was my simplex. You understood this? If you guys don't say anything, we won't be able to make it understandable. So I need to understand how much you guys are getting. Though simplex is can, like, that is fine, the example I gave, but simplex is a mode where what happens is, uh, we had those non-USB keyboards and mouse. They could only send data in one direction, so that was where simplex was used. Now next was my half duplex. What happens here is, I have one channel, and over that channel I can send data or receive data at a time. Both cannot happen. Then we have this full duplex where you can send and receive data at the same time. That is perfectly acceptable and that is perfectly possible. So first we discuss these three things. In case I talk about half duplex, so I gave you an example of walkie-talkie. Now what happens with this walkie-talkie is, you speak something, the person at the other end, he only listens. Now he opens his channel and he starts speaking, and you now become the uh, receiver, like, you only can listen. So that is my half duplex. Another example of simplex can be any kind of broadcast. Now my TV can receive, this channel can only be used to receive data, not to send data. So my TV cannot send any data. The previous televisions that we had, so we had those stations, they would transmit or broadcast some movies, and I would receive that. So that was my simplex. It was followed by half duplex, where you had those walkie talkies. This was followed by my full duplex. Full duplex was where I can send and receive data at the same time. The best example can be a telephone. So even like 30 years, 40 years back, we had those telephones where I could speak, and I could listen at the same time. Though, if I am speaking and listening at the same time, I won't be able to understand. That is not a problem of the communication channel. That is my problem. So that was full duplex, but I could. Now you are speaking and I speak at the same time, that will interrupt you. But both the communication happened at the same time. I hope this was understandable to everyone. Please confirm. Just please keep on speaking. That would we want to make uh, it a little more clear. We need to keep talking. So this was my simplex, half duplex, and full duplex. Then we talked about something called synchronous and asynchronous. Synchronous and asynchronous. In synchronous transmission, what happens is this would be a good example of synchronous transmission. Now, what happens is as a receiver, I send a request. Now, once you have my request, ki, I need something, what you do is you send a synchronizing signal. This synchronizing signal, the first bit of this packet would be a synchronous bit, synchronizing bit. Now that synchronizing bit, what it does is it will start this channel. Now we took this example, or let us draw it again. Synchronous. Now suppose this is the server, this is the one who is supposed to send anything to you. Now suppose I am making it a bus configuration for you guys to understand easily, but it can be any kind of configuration. Now, with synchronous transmission, what happens is he asks a request. He sends a request. This request is sent to the send. He would be the sender, and he would be the receiver. Now, once he gets a request, what he does is he creates a logical channel. Okay, this is the easiest possible route to this system. And once it sends a synchronizing signal, the channel, this logical channel is blocked. And only this sender would be sending data to this receiver on this logical channel. No one else can use it, and no other communication will go on at this time. Fine. Now we have that sync signal that would be followed by that sync bit that would be followed by an acknowledgement signal. And once this acknowledgement signal has been acknowledged, the transmission, this channel has been created. Once this channel has been created, transmission would start through this channel only. No other channel would be used. So this is my synchronous transmission. Now this can be followed by my asynchronous transmission. The receiver sends a request. And now once he gets the request, what he does is he sends the packets over this channel. This channel would get a lot of, this channel would receive some data or data packets. There is some data. Now that data would transfer, or would be transmitted on this bus, and each of the devices will get that data. Now, mm, every data what we are doing is we are not sending data only as plain. Okay, like this is my signal 10010. We are not sending it like this. What we are doing is we are making this into data packets. A large block of data that was 1 GB is converted to small datagrams. Those datagrams are this big data is being converted to chunks of data. That chunk is being created into datagrams, and datagrams can be said to be my packets. So that is broken, and once we have the blocks, those chunks of blocks would be again broken. And after breaking, we are getting something as we call as data packets. Data packets. Because if we are trying to send a very large file, the channel might get uh, stuck. It might cause a lot of problem to my uh, data bus. Since every data bus has its own capabilities. So I have this data bit. What I do is I convert it into data packets. Now, data packets, we will talk about how a data packet looks like and what are the different formats that we can have for our data packets. So we will be talking about that. But before we move to those data packets, let us understand the asynchronous transmission. Now, this packet is being transmitted on this bus. Every computer on this bus will receive this data. He will also receive, he will also receive, he will also receive, he will also receive. So we need to add, since he has requested, so the sender knows who is supposed to receive this data. In that case, we need to understand, or we need to just imagine that this data should be made into packets. That packets should have something called a destination, like who is supposed to receive this data bit. And it also should contain another field that should be the source, like where it originated. I might send requests to 5 different locations. Now everyone would be getting like how would I know where it came from? So it should be like that. Now a large data block is being converted to small packets, so I should have the exact number, the somewhat comparable to the page number. I am getting 10 pages and I don't know which page is where. Like I hope that is understandable by you all. Suppose we are getting a movie, and what we they have done is 50 MB 50 MB broken, 50 MB, 50 MB, 50 MB. So you need to know which part to watch first and which part to watch second, similar to our episodes. So that is the packet location that should be there. What else should be there? Other important field should be the checksum. Now somehow I should know that this data that I have received is correct. That should also be there. So that is also there. We call it checksum. Now checksum, what happens is each machine on this network knows that the checksum field should be something like 111. Now when he receives the data packet, he checks the checksum and converts puts it into a function. That function is supposed to produce a series like 111. But what happens is it does not receive, it gets something like 101. So this will mean that this communication channel has some error. And since it is 101, that means 10 or 10 has been removed from this. So the complete data can be corrected by removing another 10 from the whole data set. So the function can help you understand whether the packet I have received is correct or not. So that is my checksum. And that should be followed by my data. So this is what was needed, and for that we created those data packets. Now then we came up with another discussion on protocols. Since again everyone has its own rules. Now I can communicate in different ways. So every way would have its own idea. Now suppose a protocol is a set of rules. Now my set of rules, in case someone comes to Bihar, set of rules means what? Some dignitary coming to my office, he would be treated, and that everything is a protocol. Now he comes to Bihar. Now what happens is I receive him at 9:30. 10 minutes, he comes to my NSTI. In my NSTI, he has a brief introduction with all the people there. So 9:50 is there. 9:50 to 10, he is supposed to have his breakfast. Now, in breakfast, in case he is in Bihar, he will get something like the North Indian food, might be litti chokha, might be puri sabzi. Now, suppose he goes to Tamil Nadu, he would be again, most of the things would remain same, but he would be given a breakfast, might be at the later time, since or he would be getting South Indian food, that is idli, or might be vada, or might be mm, anything else. So that protocol depends upon no, these packets would depend on the protocol it would differ for each protocol, but these things will remain the same. So we created this data packet in our first session. Almost same thing would remain there. A little difference would be there. I'm not saying everywhere you would be getting the same. Now this is my TCP that was having a little different, but you can see you have the same header length, you are having the same source address, destination address, checksum, length. So most of the things would remain same, but with each protocol you would be getting a different packet structure. I hope till now that made some sense to everyone. If not, let me know. We can talk about it again. I can see many of you have not joined. Like the number has dropped substantially. No, why would that be? 19 only. It's like 18 only. Any particular reason why most of you are not there? Yep, guys, please. Did that made any sense? I hope you guys are there and you can hear me. Fine, that made some sense to most of you. Now that I hope you guys now have understanding what data packets are. Please let me know yes or no. Now, in case you want to define data packets, so you can define it like small units of data that are transferred over on communication channel or in a network. So that is how you can define a data packet. Hmm. Uh, yeah. So now that brings us to our concern. That also brings us to this is what we were discussing. The different protocols. Protocols we understood that is a set of rules on how to make a communication between two devices. So we were talking about the first that was my TCP protocol, that was transmission control protocol. So we would come to the theoretical part later, but let us transmission control protocol. But let us understand something. So in case we talk about the TCP, let me draw. I am really very bad at drawing, so excuse me for my drawing. I hope I have started the recording. Recording is there. Fine, good. So this is my packet. Uh, yes. So 0 to 31. So in case you count from 0 to 31, that will make 32. So a total of 32 bits. Normally we are having using 32-bit addressing. We can use 64 or yeah, like 8-bit run, 8-bit. We can use 16-bit. 32-bit is the most commonly used. You can also have 64-bit transmission. So fine. So we are not concerned about the others. 32-bit is the most widely used transmission. So the first field that we are having for our TCP protocol 0 to 15 and 15 to 31. The first is my source and the next is my destination. We talked about the source and the destination, where it has originated, like which is the computer that is sending this, suppose this one. So that is my source address, that is followed by my destination. So destination is where I am receiving it. Now, in case someone else receives this, he will know that this packet was not supposed to be sent to me. So he will remove it. Like he will not use it. He will not process it. So we would be having something called the time to live. The protocol, yeah, the packet would die in that range. This would be followed by my sequence number. So this is again something we talked about the sequence number. Uh, where to put this packet? Mm, the something comparable to my page number. So that is 16-bit. This is also 16-bit, but this is 32-bit. Then we would be having an acknowledgement in case a logical channel is created. So acknowledgement number. Now the same thing would be can be used for several transmission. So we should know, okay, for which transmission we are sending. Now Suppose a logical channel has been created, or logical channel has, even if it is not created, now what happens is I make 5 requests to this computer. He will send data, but I should know he is sending for which communication or which request. So that would come from my acknowledgement number. This would be followed by certain flags that would help us understand a few more things, like the length of the header, how long the header is. That would be followed by packet length, MLT. That would be followed by a reserved flag that has a certain function that I would tell you. Then that would be followed by certain bits. These would be a total of 16 ports or 16 bits. That would be followed by another offset. This would be followed by a checksum. What this checksum does is it will help you to know whether we have received the correct packet or not. So there is no changes in the packet that was sent. Like I sent you a letter, no one has opened it in between, no changes are there, it has been received as it is, so no corruption has crept in. Then we have certain pointers, there are another flags that would be followed by some optional bits. We can talk about optional bits. That would be followed by a padding. These all are 16 bits each. That would be followed by your data, the real data. So I am not sure if that makes any sense, but at least you guys did see how it is and how our packet looks like. Now, let us take each of these one by one. Yeah. The first is my source port. I hope most of you were able to understand the source port, where this data packet has originated, where it has come from. That is followed by my destination port, where it is supposed to reach. Importance of this destination port is if it receives any other port, it will say that I am at a different location that is not supposed to be mine, and they will not use it. That would be followed by my sequence number. Now, sequence number, again, I believe you guys understood that this means uh, where it should be put. That is my sequence number. That would be followed by my acknowledgement number. Sorry. Acknowledgement number. So acknowledgement number, with each transmission, you are increasing it by one to make you understand that on which bit you are or on which communication you are. So that is my acknowledgement number. Now suppose you receive 5 packets, so that would be counted to 5. So that is my acknowledgement number. Then we have these offsets, the offsets. That might not be very important, but still we should know. So this offset will the this offset, or let us call it the header length, h length, the header length. This will tell you the length of the header. That would be followed by some reserve bits. These reserve bits are normally kept at 0, and they might not be changed. They are just to fill in the blank. Now, what do I put here? So keep it reserved, make it to 0. Then we have some control flags, or let us call them only flags. So these flags, a total of, I believe, 9 different flags are used in TCP communication. And what happens is these fill the purpose. Now, suppose the communication channel brings to a halt, comes to a halt. In that case, I should know, like whenever I start again, I should start with a 0 number or a reset. So they can be used to reset my communication channel. Then we have these offsets. They might be called as window, offset window. So this window is again a checksum, but it checks the header, like whether there is any error in the header. So this is the header checksum. This is the normal usage of it. Then we have this again. The next is my checksum. That helps me with the checksum. This helps me with the authenticity or the correctness of my data. So this is what I have told you. That would be followed by my pointer. This is again a flag that is referred to as urgent, and urgent or control. Yeah, like these flags are used for controlling. Hmm, what should I tell you? This helps you in understanding the sequence number of the data bits that are being transferred. That is the pointer pointing the data where it is, and there that can be having a value of 0 or 1. Then that would be followed by my some optional fields. That is my MTCP data. That would be again with the pointer, yeah, with the not with the pointers. Hmm, fine, it is not accepting. Okay. So these optional data might not be yeah, usable every time, but in case we are talking about very high bandwidth networks where at the same time different devices are sending and receiving data, there this optional data might be checked out. Now this might contain selective acknowledgements for each data pair or for each data packet. So that might not be very useful for us. That would be followed by my data or my payload, the exact data that I am transferring. So that is my data or the payload where you are sending the exact data. So this is how my transmission control protocol looks like. Now I am not sure if uh, that was useful for anyone or you guys understood. You guys understood or not? We are getting like more and more people are moving out. I don't know why. Yep, guys. Now, anyone would like to ask anything? That would be right after. Yes, Akash, hard to remember it all. That is very true. And look, this is just a theoretical part. You might not need to remember all this. You simply need to know how to how to implement a network, how to implement a UDP protocol, or how to implement a TCP protocol. This is not something you would be needing to remember. That would not be needed. And getting back, we have another question from Mukesh. Obviously, Mukesh, even I am looking forward. Now, even I believe these things, in case they are being taught in offline mode, that would be much easier to learn and to understand. Even I am not finding it even I am finding it quite difficult to demonstrate, since if I had sat with you, I would have made you understand in a much better manner. So that is what I feel. But hopefully, right after Dasera, we would be starting our offline classes. Now, anything else, anyone? This week might be. And when are your NSTI going to close for vacations? Like how many days? Now this was okay. We can discuss that later. So getting back to my TCP protocol. Hmm, okay. Fine. So let us understand a few things about the TCP protocol. So TCP protocol, though we saw the header is really very quite heavy, and some of the protocols would be having a much easier header and the datagram. So for some, it would be really very easy. But still, TCP is the most widely used protocol on the internet. Most widely. It's like most used protocol. Protocol on the internet. So that is the first and the foremost thing about the TCP protocol. Next, it provides you with the end-to-end delivery. End-to-end delivery of packets. So that is another major advantage of TCP protocol. The transmission would start from here and it will complete. So that is what we have. And one more thing that I should have told you right there. Now, we talked about some checksums, the header checksum and this checksum. So these offsets. So what these checksums do is, okay, like suppose I receive a faulty data. Now that faulty data I would be providing with a pointer. Okay, like this, I will be flagging this to zero. This pointer flag would be made to zero. And once it is made to zero, the sender will again send this packet. This packet would be sent again. This is why TCP protocol is most widely used and especially for downloads. This allows you full duplex transmission. You can send and receive at the same time. It provides you with stability, very stable. Another major advantage, the checksum, the sequence number, the acknowledgement number helps you in error checking. Error checking. Now, this error checking is because each packet is indexed packets, and they have checksums. So these are the major advantages of my uh, TCP protocol. I hope that was understandable for everyone. Now, you guys understand the OSI model, the TCP IP model? Do you guys know or have at least heard of? I am talking about OSI model and the TCP IP model, the seven layered model. I would say. You guys have heard about it, I believe. Fine. So I'm not sure if you have heard about that, or you guys know about that. Not a problem. So mm, first we designed something called the OSI Open System Interconnect model that was followed by the TCP/IP model. Now the problem was with OSI model was it was never implemented. That is only theoretical, no practical implementation. Fine, not that is again not our concern. So what this OSI model was, it was seven layered. The top layer was the application layer, where all those applications would work. And the final layer was my physical layer. The final layer was my physical layer. Physical layer. This application was followed by a presentation layer. Presentation layer. This was followed by a session layer. Session. This session layer was followed by a transport layer. This was followed by a network layer. This network layer was followed by data link layer that had a something called a max sublayer within it. So these were the seven layers in my OSI model. Now again, like if you haven't heard a lot about it, so this might be a little confusing to understand each and every layer. So let us not talk about each and every layer, how things go. But let us understand a little about these models. So someone is trying to write, Ganga, I don't understand. This is, do we have class tomorrow? Uh, I would be working on each day except for the 10th. Yeah, like not 10th, that means 5th. So in case your NSTI permits, then I would be having a class tomorrow and on Thursday also. So only 5th we won't be working. We can have a session on 4th, we can have a session on 6th as well. Only 5th we won't be having a session. So it is upon you to decide, upon your NSTI to take a call. In case they permit, we certainly would be having. Fine. So you guys might talk take that later. Uh, so can you help me? We were talking about this OSI model. Can anyone help me? Where does the exact transmission occur? To which layer? Now, what do you think this application layer would be doing? So let us not go into very deep. But this application layer is where you are interacting with the machine, with the data, with the information that is being provided through the network. So this is in the same form I am sending. So I am using this one node, and here I am writing something and you are receiving it. So we all, both of us, you and me, we are working on this application there that is providing me with the data and information in such a manner that it is usable for each and everyone. So I believe you guys understood this. That now this is me who is creating this node, and this is you who is receiving this node as it is I am doing. Now, this is not being transferred in, like, this image is not being transferred. It is being broken up into uh, yeah, small data packets. This is being converted to zeros and ones, and that zeros and ones are being transmitted. I believe you understand that. So you are interacting with these applications. Now that is followed by my presentation layer. Now presentation layer is about, now I hope you understand the term presentation. So it is concerned with changing the data into upper or lower level. Suppose I am sending this image. So this presentation layer is transmitting my application into more usable format for the computer networks. It is also doing the encryption and the decryption. So in case we are talking about cryptography, cryptography is implemented in the presentation there. So this is only changing the data into a format more usable, either in case it is the sending end, so it has to convert this data into more usable format for the for the transmission, and here for the application. So then we have the session layer. Now this session layer creates this logical channel. This helps in maintaining this logical channel or the transmission. Like it creates a session, maintains that session or the connection session, or the makes maintains and stops this channel on which data is being transported. Then we have the transport layer. So this will define which protocol to use, and based upon that protocol format, it will be transmitting your data. So they will either define TCP protocol or UDP protocol based upon the hardware and the technology that you are using. So they will define the data and the protocols, and they are doing the transmission. Then we have this network layer. So network layer will define the path, the physical path for a network, for a transmission. Then that is followed by my DLL, that is my data link layer. It defines the format, the data format. Means like what kind of packets I am going to send, what would be the packet, like we define these packets. Those packets are being defined by my data layer, data link layer, and that is followed by my physical layer. Now this physical layer is doing nothing, but it is transmitting the exact data packets or the whatever data is over this channel. So the exact transmission is being maintained by this physical layer. I am using the application layer, and the channels or those ports, they are using the physical layer. I hope you guys were able to understand this. So let us talk about our TCP IP model. TCP model. So here we are having only 4 layers. They are coming up with the 5th layer also, but let us talk about what we had since the beginning, the 4 layers. The first is my application layer. The same thing, the same function it has. The application layer, it is allowing you to interact with the communication channel. So that is my application layer. That would be followed by a transport layer. Transport layer. That would be followed by my internet layer. And that is followed by my interface layer, network interface. The same thing on the other end as well. So the same thing on the other end. The network interface layer is providing you the interface with the physical media. The medium that you are using, it is doing that. Now this internet layer, it provides you with the location, the source, the IP address, and uh, the routing, and uh, mm, the IP version. So it is providing you with the source, destination address, and everything. Now this transport layer is involved in uh, the delivery. In case we talk about delivery, it is doing segmentation. It is doing what this presentation layer was doing, what this session layer was doing, and what this transport layer was doing. So it is doing the presentation, it is doing the encryption, it is creating a session on this channel, and it is involved in the transport of the data, end-to-end delivery, and the presentation of data, the encryption of data, making the data into the format which is usable by the next layer, be it application layer or be it the transport, yeah, with the internet layer. So this is the TCP IP model. I'm not sure how much clear that it was with you all. Yep, guys, please let me know how much clarity that was for you. Ganga, I hope we have talked about tomorrow. So it is upon you to let me know. Meanwhile, I am planning to have a session, but it depends upon you. In case the now, how many of you are still there in the NSTI? That is a question that I asked in the beginning only. So all of you are still there in the NSTIs, right? Great. So is your NSTI working, or yeah, like are they allowing you classes tomorrow? Are they open? No class in our NSTI. Now, what does the and when we would be starting again, like when you would be back, means like after the Sera, tomorrow puja celebration, I understand. Now, tomorrow and day after tomorrow, both days we have the celebration. And how about the 6th? No, that is fine. How about 6th? Uh, is your NSTI open on the 6th? 6th will, okay, fine. So, it's like, what do you guys think? Should we continue tomorrow? Not tomorrow. What about Calicut? Fine. So I understand. I will. How about Calicut? How about you guys? Sir, everyone. I understand. No, fine. No, I need to. I understand, but I need to have. Calicut tomorrow class open fifth close. So, you guys would be there in the NSCI. So, what? Uh, Fine, fine. I understand. I understand. Not a problem. So, uh, mm, Mukesh, you have my number, and Ganga, you have my number. So, what you can do is you can ping me on WhatsApp, personally. Whatever decisions we take, I would pass it over to you all. So Mukesh, we are like you guys are not working on, yeah, like you are working to tomorrow, and Trivandrum is not working tomorrow. So fine. So I will connect with the NSTI proctors or POCs, and I will let you know. So in case we continue tomorrow, depending upon the whatever comes from your POC, in case Trivandrum does not go for a class, what we can do is tomorrow is we can have a small get together tomorrow, uh, talk out our minds, uh, not learn something new, but try something else. We won't be learning something new, we won't be carrying on with our course. We will be doing something else. So that won't affect anyone, but we would also remain engaged. So both things we need to take care of. So uh, I would suggest both of you to ping me personally. I will let you guys know. I have texted. Uh, Chennai is not there, I believe. Calicut, who is Prasad sir is your who is the POC? Okay, let me.
Sir, can you stop today class at 4?
I am thinking of, since most of you seem to be moving out. So again, that is what I can do. Now, is there something?
Sir, we have to prepare for puja.
For puja? Okay, fine. Fine. In that case, we might drop. Let me stop recording. So in that case, we